This is episode 1 of the chemistry podcast revision. In the first episode, we will revise your organic chemistry nomenclature, that is, on the naming of organic compounds. Okay, let's first take an overview of what you need to know for organic chemistry. Okay, so this topic has two main parts. Okay, one part on the compounds and the second part on the organic reactions. Okay, we'll talk about organic reactions later on in episode 2. Okay, now for this time we will just focus on organic compounds. The first thing you need to know about the organic compounds is how to calculate the molecular formula. Okay, now this is stuff you did last year, so I'm not going to go through it again. So the stuff that you did this year include how to draw chemical structures, how to name the compounds, and how to identify the isomers. Okay, now you may be wondering, how difficult or what kind of structures would I be required to draw? Okay, do I need to draw really complicated things, like this guy, or maybe this one, and use these shorthand drawings? Well, the answer is you don't have to draw anything so complicated. We only expect you to draw simple organic compounds. What? This is simple, isn't it? Okay, it really helps if you can count up to 4 at least. Okay, if you can know the number of bonds that are attached to each type of atom. So carbon has 4 bonds, nitrogen has 3 bonds, oxygen has 2, hydrogen and the halogens, that is fluorine, chlorine, bromine, okay, and so on, and iodine has 1 bond. Okay, I hope that's not too difficult to remember. If you have the number of bonds correct, your structure will be correct. It has to be. Okay? Now, after you can draw the structures, you need to be able to name them correctly. So, there are some rules to naming organic compounds. Now, every organic compound name has 3 parts. The first part is the family name, or rather the end of the name is the family name. Okay, so that is your homologous series names. You have your alkanes, okay, your alkenes, your alcohols, and your carboxylic acids. Okay, so these are the 4 that you learned this year, and of course there are many more which you will learn next year. Then the second part of the name, or the middle part of the name, is to identify the longest chain. Okay, the longest chain must be connected by carbon atoms. Sometimes the longest chain is hidden deep inside the compound, but find it. Okay, find the longest chain and you give it its name. You start with methane has 1 carbon atom, ethane has 2, propane has 3, butane has 4, pentane has 5, hexane has 6. Now you have to know at least up to 6 carbon atoms long, but it would be much better if you could learn up to 10. Okay, decane, which is 10. And then after the longest chain, after you've found the longest chain, you look for all the things that are attached to the chain. Okay, all your little substituents, the non-hydrogen things that are attached to the chain. Okay, if there is more than 1 substituent, you need to add these prefixes. Okay, 2 for di, 3 you need tri, 4 for tetra, and 5 is penta, and so on. Again, it'll be good if you can remember up to 10 what it's called. Okay, which is deca, by the way. DECA. Okay, now if you have more than 1 family inside the organic compound, okay, more than 1 functional group, then always have the carboxylic acid at carbon number 1. Okay, that's the most important, if you like, functional group, followed by the alcohol, okay, then the alkene, and then all the rest of the substituents. There are several rules you have to remember when it comes to naming organic compounds. Okay, the first one is to name the substituents in alphabetical order. For example, if you have chloro and fluoro, then C, chloro, comes before F, fluoro. Okay, the second rule is to number the carbon atoms so that the name has the smallest numbers. Okay, the smallest numbers. And when you're writing the name out, remember a dash goes between a number and an alphabet, okay, and a comma is placed only between numbers. Now that means if you put a dash where a dash doesn't belong, I will mark you wrong. Now, if you put spaces where spaces don't belong, I will tend to ignore that. Okay, just for your information. So let's try a little exercise where you see if you can spot a mistake in these names. Okay, so you might want to hit your pause button here so that you can give naming this compound a go. Okay, otherwise just follow along. Now, the longest carbon chain in this compound is 4. Okay, here, so we call this butanol. Okay, because of the OH group. Now, obviously, butanol here, the OH group has the priority, the alcohol has the priority, so this must be carbon number 1. Okay, if this is carbon number 1, so this obviously is the wrong answer. Okay, here is another mistake. We don't put a dash between two alphabets, remember? Okay, now if this is carbon number 1, then this is carbon number 2 and 3 and 4. Okay, which means that the chloro group is actually on carbon number 2. So this is also wrong, and the methyl group is on carbon number 3. Okay, so what about this one? What's wrong with this name? Okay, it seems to have everything right, except again the dash is in the wrong place. But now, if you look at this 2 here, okay, in alphabetical order, remember? So chloro before methyl, and the correct name is 2-chloro 3-methyl butan 1-ol. Okay, did you get that one? Right, now take a look at this one and see if you can spot the mistakes. Press the pause button on your player now and try to spot the mistakes. Then press play again when you have found them. Okay, so where are the mistakes? First of all, in the first case, this one is wrong in alphabetical order, okay, because the bromo B should come before chloro C, which is before methyl. So this is wrong in alphabetical order, but this one is correct. Okay. Secondly, you have all your dashes in the wrong places. This is wrong as well. It should be a comma, so that is correct. Okay. And thirdly, the numbering is wrong. Okay, you should number the carbon atoms from this side, so you have your substituents on the carbon number 2 and number 3. Okay, so the correct name is 3-bromo 2,3-dichloro 2-methyl pentane. Okay, did you get that one? Next, we come to identifying isomers. Okay, now isomers are really easy when it's structural isomers. So you're looking for something that has the same molecular formula but a different structural formula. Okay, so this is the example that was in the previous slide. Okay, all you need to do to find isomers of this compound is to rearrange the substituents. Okay, for example, if you move this over here and you put the bromine there, and you move the chlorine into here and you move this over there, and so on and so forth. Okay, if you can name them differently, then they are different compounds. Okay, I'm not going to go through any more than that. The other type of isomers you need to know are your geometric isomers or the cis-trans isomers. Okay, so for cis-trans isomers to exist, you must have non-hydrogen substituents on different carbons, okay, and there must be a double bond. Okay, so something like this where you have two different substituents, okay, two non-hydrogen substituents on different carbons, okay, on where they have double bond in between. Okay, so if they're on the same carbon atom, like if I had chlorine here and hydrogen here, then that would not have any cis-trans isomers. Okay, so I think that brings us to the end of this episode. Okay, next episode we will talk about organic reactions. Okay, see you next time. Bye bye.